Good day, I am Onyike Innocent by name. You are welcome to the masterclass. I'm going to be treating Jamb Waec question in mathematics set theory. Do well to subscribe and turn on your notification button and like the video as well in order to be updated anytime I post a new video that will enable you ace your forthcoming examination. Alright, I hope you're familiar with set theory, subset, set properties, set cardinality, power set, and Venn diagram. Question 1. In a class of 80 students, every student studies economics or geography or both. If 65 students study economics and 50 study geography, how many students study both subjects? This question we are asked to find the intersection between what? The number of students that studies economics and geography. Now, let's solve this question step by step. In a class of 80 students, that means the universal set here is what? 80. Then number of students that study both subjects is what? 80, which is the universal set here. So economics union geography equals to 80. Now number of students that study economics is given by what? 65. Number of students that study geography is what? 50. And we are asked to find what? How many students study both, which is the what? Intersection between economics and geography. Now let's write this down in a formulated way. Now this is a formula to apply when solving two set problem. Very quick and very fast. So 80 is equals to 65 plus 50 minus the intersection of economics and geography. So 80 is equals to 115 minus the intersection between economics and geography. So crossing the 115, the sign changes to negative and economics and geography. So this gives us negative 35 and it's equals to negative n. The intersection between the economics and geography. So the answer is what? 35. So 35 students studied both economics and geography. So the correct option is what? A. Now we move to question 2, Jamb 2001. Following the same approach as question 1. Here we are asked to find what? The number of A union B. So let's apply the formula we also applied in question 1. So A union B is equal to number of A plus number of B. Very fast and very interesting too. Number of A intersection B. So now let's substitute. 6 plus 5 minus the intersection, which is 2. So this is equal to what? 11 minus 2. Number of A in B is equal to 9. Very, very fast. So C is the correct option. Now, question 3. In a school, 220 students offer biology or mathematics or both. That is the universal set now. 125 offer biology and 110 mathematics. How many offer biology but not mathematics? This question we are asked to find the number of students that studied biology but not mathematics. It means what? Biology only, simple English. So here the universal set is what? U, capital letter U. 220 can be denoted by what? L. Number of biology union mathematics 220. Number of biology now 125. Most students studied. Number of students that studied mathematics 110. So let's write this down using a formula. So biology plus number of students that study mathematics, very simple, minus number of students studying biology and mathematics. Now let's compute by substitution. So 220 is equals to 125 plus 110 minus the intersection between biology and mathematics. So 220 minus, when you add this up, this gives us what? 235. This equals to negative intersection between biology and mathematics. So gives us negative 15, right? Negative 15 is equal to negative intersection between biology and mathematics. Let's cancel this. So you can see that 15 students studied what? Both biology and what? Mathematics. Now let's compute the number of students that studied biology only. How many offer biology but not mathematics? It means what? Biology only. Now to get this, I'm just going to subtract 15 from the number of students that studied biology. So biology but not mathematics is equal to 125 minus what? 15 is equal to 110. So option D is correct. Question 4. In a class of 40 students, 32 offer mathematics, 24 offer physics, 4 offer neither mathematics nor physics. How many offer both mathematics and physics? Here, this question, they are asking you to find the intersection between mathematics and physics. So let's apply the formula. So N mathematics union physics, which is the universal set. The universal set here is what? 40. And the number of students that study mathematics is what? 32. The number of students that study physics is 24. And 4 offer neither mathematics nor what? Physics. Here you ask to find the intersection between what? Mathematics and physics. So mathematics, physics plus neither math nor physics minus what? Intersection between math and physics, which is what? Both math and physics. So 40 is equal to 32 plus 24 plus 4 minus the intersection between math and physics. So 40 is equal to what? This gives me 60. Sorry, yes, minus. So crossing 40 minus 60 is equal to negative m intersection b. So negative 20 is equal to negative n. So therefore we can see that what? 20 students studied both mathematics and what? Physics. So option A is correct. Now question 5. Given that the universal set consists of what? Even numbers between 0 and 30. P is a set of multiples of 6 between 0 and 30. Q is a multiple of 4 between 0 and 30. Find P union Q or complement. So first of all, let's list the set members. The universal set, even numbers between 0 and 30. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Set P consists of what? Multiples of 6 between 0 and 30. 6, 12, 18, 24, 30. Now set Q consists of what? Multiples of 4 between 0 and 30. So 4, 8, 12, 16, 20, 24, 28, right? Now, first of all, before we get the complement, let's first find P union Q. Our P union Q So that's combining what P and Q and arranging them in ascending order of magnitude. This gives me what the set is what 4, 6, 8, 12, 16, 18, 20, 24, 28, 30. Right? Now, to get the P union Q complement, this can be all elements in the universal set which are not found in P union Q, or the members of the universal set which are not found in P union Q. 4 is found here, so it's out. 6 is found here, out. 8 out. 12 out. 16, 18 is gone. 20 out. 24, 28, and 30. So P union Q complement is 2, 10, 14, what else? 22, right? And 26. All members of the universal set which are not found in P union Q. So this is correct. Now question 6. If X is a set of all perfect squares less than 40, and Y is a set of all odd numbers from 1 to 15, find X intersection Y. Very simple. Members of set X, all the perfect squares less than 40. So 1, 4, 9, 16, 25. Y is what? Odd numbers from 1 to 15. 1, 3, 5, 7, 9, 11, 13, 15. Now X intersection Y. We have to find the similarity between X and Y. That's the meaning of intersection. So 1 is here, and what? 9 only. 1 and 9. The rest are not what? Intersected. Now question 7. Given that set P 1, 3, 5, 7, 9 and Q set Q 2, 4, 6, 8, 10, 12. Determine the relationship between P and Q. For us to determine the relationship between P and Q, we are going to use the option to solve that. So P intersection Q is equals to null set. Yes, of course. We can view, is there any similarity between P and Q? No. These are all sets of odd numbers. These are all sets of even numbers. So there's no relationship or intersection between even numbers and odd numbers. So this is very correct. Now P is a subset of Q. This C means what? Subset. P is a subset. Now the subset sign means what? P is what? Contained or found in Q. But looking at this, there's no element in Q. P is not rather found in Q. P is not found in Q, so this is wrong. All of P are not found in Q, so therefore this option is wrong. Now Q is a subset of P. Are all the members in Q found in P? No, so this is wrong too. P is equals to Q. Very, very wrong. This is not equal, so only option A is the correct answer. So question number 8, Jamb 2008. A bookseller sells mathematics and English books. If 30 customers buy mathematics books, 20 customers buy English books, and 10 customers buy the 2 books, how many customers has he altogether? So here you're asked to compute the universal set between the two. So for us to compute this is what? Number of customers that purchase mathematics books and English. So this is there. I have to compute this. So number of mathematics customers is what? Given by how many? 30. Yeah, 30. Number of English customers 20, the number of both mathematics and English, so the intersection between mathematics and English is what? 10. So let's apply the formula. (30 plus 20 minus 10). So 50 minus 10 equals to 40. So 40 is the correct option. Hope you know the formula. The formula is given by M in E is equals to number of M plus number of E minus number of M in intersection E. So that's it here. Now question number 9. If set x n squared plus 1 where n is a positive integer and it ranges from what? 1 to 5, and set y consists of 5n where n is a positive integer as well and ranges from 1 to 5. Find x intersection y. First of all, let's list the elements or members of set x or in y. So x ranges from what? N ranges from what? 1 to 5. So 1, 2, 3, 4, 5. So now when n is equals to 1, this gives us what? 1 squared plus 1 is what? 2. When n is equals to 2, 2 squared plus 1 is 5. When n is equals to 3, 3 squared is what? 9 plus 1, 10. When n is equals to 4, 4 squared is what? 16 plus 1 is what? 17. When n is equals to 5, 5 squared is what? 25 plus 1 is what? 26. Now, members of sets y. And know that n ranges from what? 1 to 5 as well. 1, 2, 3, 4, 5. Now, when n is equals to 1, 5 times 1 is 5. When n is equals to 2, 5 times 2 is what? 10. When n is equals to 3, 5 times 3 is 15. When n is equals to 4, 5 times 4 is 20. When n is equals to 5, 5 times 5 is what? 25. Now, x intersection y. We are asked to find what the similarity between x and y. We can see that 5 is common here, as well as what? 10, as well as what? Which other run? Finish. So 5 and what? 10, right? This is 26. So 5 and 10. So is what? The correct option. So question number 10. You move. If set x consists of n squared plus 1 when n is equals to 0, 1, 2, 3. 0, 2, 3, not 1. And set y is n plus 1 where n is equals to 2, 3, 5. Find x intersection y. So let's first of all list the members of set x where n is equals to 0, 1. When n is equals to 2, 2 squared plus 1 is 5. When n is equals to 3, 3 squared plus 1 is 10. Now, members of set y. When n is equals to 2, 2 plus 1 is 3. When n is equals to 3, 3 plus 1 is 4. When n is equals to 5, 5 plus 1 is 6. Now, x intersection y is equals to what? In null set, there's nothing common between x and y. Or, so option C is correct. Now, question number 11. S intersection T intersection W is equals to X. S union T union W is equals to W. T intersection W is equals to S. If S is a subset of T and T is a subset of W, which of the following statements above are true? A, I and I. First of all, let's compute this. S is a subset of T and W. This tells us that what the smallest set here is what S. Since S is contained in T as well contained in W again. So it means that what S is the smallest. So if we should intersect all this, you see that what S will be what is common. S is found in T and S is also found in what W. So if you make S intersection T, we give you S, and T again intersection W, so we give you what S, because what S is the smallest what set here. So A is valid, I option is valid. Now S union T union W. You see, now since everything here, all the members here are the same in terms of S, when you try to unite everything, W is the highest set here. W is the largest set. So if you unite everything, it gives you also what W. As I explained earlier on, when you unite sets, it's what gives you the W, arranging the set in what ascending order of magnitude. Because S is found in W, T is also found in W, so there will be no repetition. So in the unity of all these sets gives you also what the W, so this is valid. Now the third one, T intersection W equals S. Now when you intersect small set in a larger set, the resulting set will be what the smaller set. So but here is what S, which is wrong. It has to be what T rather than what S. So this is strong. So I and II are correct, which is what A. Now question 12 down 2011. This is the Venn diagram. From the diagram, the complement of sets P intersection Q is given by, first of all, let's write down P intersection Q is what C. P intersection Q is what C. When the two sets meet is what I C. Now let's find the complement. Complement of P intersection Q means that all elements in the universal set which are not found in what P intersection Q. Now the elements of the universal set is what A, B, C, D, E. A, B, C, D, E. Yes. So now all members of the universal set which are not found in what P union Q. So it means that C cancels C out. So this gives us what A, B, D, and E. So this is correct. Option A is right. Now, given that, this is a very cheap question, very cheap question. Given that number of P is equals to 19, number of P in Q is 8, number of P intersection Q is 7, find number of Q. Very simple, as I've explained earlier on. Let's find out the formula first. Now let's substitute the values. Just 8 is equals to what? 19 plus number of Q minus what? The intersection is what? 7, right? So 38 is equals to, subtracting 7 from 19, you have what? 12, right? Plus number of Q. So 38 minus 12 is equals to number of Q. All these set questions are very cheap, very cheap. In short, they are all bonus questions for you. So 38 minus 12 is give us what? 26. So number of Q is equals to what? 26. Very cheap. Now question 14. Given that set A 1, 5, 7 and set B 3, 9, 12, 15. Set C 2, 4, 6, 8, and find A union B union C. Here this question is very cheap. You're asking you to what? Combine all the sets in ascending order of magnitude. So we'll just write them down, arrange them in ascending order of magnitude: 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 15. So option A is correct. Now let's move to question number 15. Given that S and T are sets of real numbers such that set S ranges from 0 to 5 and set T ranges from -2 -1 to 2. So this means that x is what greater than negative 2 and x what less than what 3. So set s from what 0 to 5. So 0 is inclusive because of what is less than or equal to sign. So 0, 1, 2, 3, 4, 5. Now t, there's no line under it, so it's what from what negative 1, x is greater than what negative 2, and you know that negative 1 is greater than what negative what 2, right? I hope you're aware. That negative 1 is greater than a negative 2. So negative 1, 0, 1, 2, this is where it ends. So now uniting s union t, it gives us what negative 1 to what 5. That's arranging them in what in ascending order of magnitude. Very, very simple and short. Question 16. Given that set z 1, 2, 4, 5, what is the power set of z? Power set is what 2 exponent the cardinality of the set. Here the cardinality is the measure of or the size of the set. So the size of this set is what 1, 2, 3, 4. So the cardinality is 4. So power set is what 2 exponent n. So 2 exponent 4 is what 16. Very, very simple and short. So A is correct. No time to waste. So therefore power set is what 2 exponent the set cardinality. Very, very simple. Question 17. X and y are two sets such that n number of x is 15, number of y is 12, and number of x intersection y is 7. Very, very simple. All these simple questions. What is wrong with these Jamb people at all? I hope you can solve this now. Very, very simple and light. This is our bonus question for you. Very, very simple. So let's substitute. Number of x is what 15, number of y is 12, intersection is 7, 27 minus 7, so number of x union y is what 20. Very, very simple. Now we are touching a Venn diagram. The Venn diagram shows a class of 50 students with their games they play. How many students play? Only 2 games. Oh, very, very simple. To compute the number of students that played 1 game is what all these values 7, 6, and 10. That is summing 7, 6, and 10. That's for only one game. The number of students that play 2 games is what the summation of what 8, 4, and 3. So 8 plus 4 plus 3. It gives us what 15. So A is correct. And the number of students that played only 1 game is what only 3. All the 3 games is what 2. For only 1 game, 7 plus 6 plus 10. For 2 games, 8 plus 4 plus 3. All the 3 is what 2, because this is what the intersection of the whole games. I hope it's very, very clear. Very, very simple and very, very short. Now we move to the next question. Now this kind of set problem, you have to list the set members. So if set m x ranges from what 3 to 7, so set m 3, 4, 5, 6, 7. X is less than 8, so it has to end in 7. And set n x is what greater than, this is 8 less than x. It can also be interpreted as what x is greater than what than 8. 8 is less than x means what s is what greater than what 8. So for set n, so from 9 down to what 12, so 9, 10, 11, and 12. 12 is included because of what? The sign beneath, the line beneath what? The sign. So which of the following is true? 8 is a member of, so let's try M intersection N first. M intersection N, no, there's no similarity at all. There's no similarity between this. M union N is what? Uniting them and arranging them in ascending order of magnitude. So 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 8 is a member of M union N. No, it's wrong. 2B is not correct. Now C is what? M intersect M. Set M intersection N is a null set, which is correct as we've done here. There's no similarity between this and this, so option C is correct. Now our last question. If set A 1, 2, 3 A, B, C and set B B, C 2, 4, 5, 6, find A minus B. Very simple. We are subtracting what? B from A. Now this is very simple to compute. B is here, B is here, C is here, C is here, 2 is here, 2 is here likewise. So what is left is what? A minus B is equal to what? 1, 3, A, 4, 5, and 6. So this is what? Your correct option. This is very, very correct. Yeah. So don't forget to like the video, subscribe to the channel, and turn on the notification button in order to be updated anytime I post a new video for you. Catch you in my next video. Goodbye.